Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
I just realized that entire time my mic was muted, and I am so glad that I realized it not 20 minutes into this. Hello, everybody. Welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And we are just so thankful that you're here. We love what we get to do every Wednesday, which is hang out and do math. We go through problems pre-K through 12. If there is something specific that you want to see me go over, don't hesitate to let me know in the comment box. I always like to include upcoming, I like to include what you specifically want me to focus on in the upcoming weeks. And so I always have a little next week section that's running. So if there is something that you want to see me go over, please let me know. This week is actually almost entirely things that other people have requested, whether it's specific problems or topics. This week is almost entirely requested by you. And that's what makes these sessions so special and so amazing, is that we can cater them to exactly what you need. If you have asked for something within the last day or so, it probably won't show up until next week. But like I said, let me know in the comment box. I am happy to include this kind of stuff in the upcoming weeks. And that's what makes these sessions so special. I am from Central Florida. I am an assistant principal, but am certified K-12 math. I absolutely love helping people with math, whether it's kids or adults or anything in between, because I love to help people feel successful in what they are doing. And so I look forward to jumping right in. So let me know in the comment box where you're from, what test are you prepping for, and the little get to know you question is going to be, are you a spaghetti or a lasagna person? Are you a spaghetti or a lasagna person? Or maybe you don't like either and you are a steak and potatoes person. I am definitely a spaghetti person. I love spaghetti with like a good thick chunky meat sauce. It's my absolute favorite. So let me know in the comment box, which one are you? Are you a spaghetti or are you a meat sauce, or are you a lasagna person? Let me know in the comment box. And we will go ahead and get started with problem number 1. If the sum of A plus B equals 10 and the equation below is true, what is the value of 2A plus B? 4 parentheses A minus B equals 8. 4 parentheses A minus B equals 8. This is such a fun problem because I'm going to tell you why. So many people shy away from a problem like this because they're like, man, I've never seen that symbol, or I've never seen that symbol. And so I just don't know what to do. Y'all, it's not that hard. That could be an X and a Y, or it could be an R and an S. It could be any two variables that you want them to be. Just because they used those Greek symbols doesn't make it scary. So if the sum, and we're going to go over some basic vocabulary just because everybody could benefit from it. If the sum, the answer to an addition problem of A and B equals 10, and the equation below is true, what is the value of this? So step 1 is I have to figure out what A and B are before I can do anything else. So I'm going to translate all of this into an equation. The sum of A and B equals 10. So we know that this is true and this is true. So what am I going to do? There's a couple things I could do. I could use substitution, or I could use elimination to solve for a single variable. Because right here I only have an A and a B, I'm actually going to use substitution. So A plus B equals 10. Subtract A or B from both sides. It doesn't matter which one. So I have B equals 10 minus A. B equals 10 minus A. Now that I have that, I can substitute this in literally for B, because B is the same thing as 10 minus A. That equal sign means the same as. B is the same as 10 minus A. So with that, I can literally take one out and put one in. So I have 4 parentheses A minus this whole thing, 10 minus A, equals 8. Now, I bracketed it for a reason, because I'm subtracting all of B. I'm subtracting that entire thing. So I have to make sure that I distribute this subtraction symbol all the way through. Otherwise, you would end up with a minus a, and a minus a is 0, and you would end up with no variable, and it wouldn't be solvable. And that's where that's going to be a common mistake that people make. So I have 4 parentheses, a minus 10, and then a minus times a minus is a plus equals 8. Now I'm literally going to simplify this using order of operations. 4 parentheses, do what's in the parentheses. A plus a is 2a minus 10. And now I'm going to distribute the 4. The distributive property says I take what's on the outside and I filter it all the way through. So 4 times 2a is 8a. 4 times negative 10 is negative 40 equals 8. Now I'm going to add 40 to both sides because I'm trying to isolate that a. So 8a equals 48. Divide both sides by 8, and I get a equals 6. A equals 6. Now that I have a equals 6, now I can plug that in. I'm going to change colors. I can plug that in for B. No, I'm sorry, for A. I can plug that in for A and solve for B. So 6 plus B equals 10. Could I plug that into here? I could also plug it into there, and I would get the same answer for B. Subtract 6 from both sides. B equals 4. Now, here's where it gets tricky. They didn't ask me for what A plus B is. They asked me for what 2A plus B is. The actual question that we're trying to solve here is what is the value of 2A plus B? That's the root question, 2A plus B. 6 times 2 is 12. 12 plus 4 is 16. And I will tell you right now that when I created this, I did this. I got the answer 10 and assumed that that was the correct answer. The correct answer for this is E, 16. That's what happens when you create your own problems, right? Sometimes that happens. All right, let's move on to problem number 2. An artist has 240 assorted paintbrushes. Small paintbrushes make up 1/4 of the artist's collection. There are 3 times as many small paintbrushes as there are medium paintbrushes, and the rest of the artist's collection are large paintbrushes. How many small and medium paintbrushes are there combined? How many small and medium paintbrushes are there combined? So, an artist has 240 assorted paintbrushes. That's the total. Small paintbrushes make up 1/4 of the artist's collection. Then we find out there are 3 times as many small paintbrushes as there are medium paintbrushes. And then the rest are large. How many small and medium paintbrushes are there combined? So if this was a problem that asked how many small paintbrushes are there, I would use my answer choices to work backwards. But in this case, that's not what they've told us. So I'm going to create multiple equations and see what I can do with it. So S is going to be small. M is going to be medium, and L is going to be large. So I know small plus medium plus large equals 240. Small paintbrushes make up 1/4 of the artist collection. So if small is 1/4, can't I just divide 240 by 4 and get how many small paintbrushes there are? If it's 1/4, I can divide 240 into 4 buckets. Those aren't equal, but we'll pretend they are. But I could divide it into 4 buckets and figure out how many small paintbrushes there are, right? So I'm going to divide 240 by 4, and that gives me 60, 60, 60, 60, right? So there are 60 small paintbrushes. 60 plus medium plus large equals 240. We are already on the right track. Now, question. How many small and medium paintbrushes are there? The answer can't be A. Because if there are 60 small and I'm adding small and medium, the answer can't be smaller than the number of small paintbrushes I have, right? So let's move on to the next section. There are 3 times as many small paintbrushes as there are medium paintbrushes. There are 3 times as many small paintbrushes as there are medium paintbrushes. So that means that there are, for every 1 medium paintbrush, there's 3 small paintbrushes. Every 1 medium paintbrush, there's 3 small paintbrushes. So 3 times medium is going to equal small, right? Divide both sides by 3. Medium equals 20. There are 3 times as many there are 3 times as many small paintbrushes as there are medium. So now we have 60 plus 20 plus L equals 240. How many small and medium paintbrushes are there combined? Y'all, I'm really winning at this whole answer choice thing today, aren't I? I'm really winning at this whole answer choice thing today. 60 plus 20 equals 80. There are 80 small and medium paintbrushes combined. Questions about that? All right, let's move on to problem number 3. Select the equation below that has no solution. Select the equation below that has no solution. So I am looking for an equation that has no solution. So what that's going to mean is that when I solve it, I'm going to get something like 4 equals 7. If I get something like 2 equals 2, that means there's an infinite number of solutions. But if I get something like 4 equals 7, there's no solution because that's not possible. So I am going to start solving each one of these and simplifying the left and the right to kind of get them to be equal on each side. I'm going to have x's on both sides and I'm going to have constants on both sides. And I'll show you what I mean by that. So A, I'm going to solve pink. I'm going to distribute this 3 all the way through. So I have 3x minus 15 plus 2x equals. And I'm going to distribute this negative 7 all the way through. 4x minus 7x minus 14. 3x plus 2x is 5x minus 15 equals 4x minus 7x is negative 3x minus 14. I'm going to leave it just like that, and I'll show you why in a minute. Letter B, distribute the negative 3 all the way through. Negative 3x minus 3 equals negative 3x. 1 minus 4 is negative 3. That right there is going to have infinite solutions. No matter what I plug in for x, it's going to give me the same answer because this side is exactly the same as this side. I don't need to finish solving that. So I know that B has a solution. It's literally infinite solutions. C, I'm going to distribute 10 plus 2 times 3 is 6x equals 9 minus 3 is 6x plus 15. I'm going to reorganize this so that each side is the same. 6x plus 10 equals 6x plus 15. I have just found the equation with no solution. And here's why. Because if I have 6x and 6x on each side, 6x, 6x, then this part should also match for us to be able to have a solution. But if I have 6x plus 10, is that ever going to equal 6x plus 15? No. If I plug in 1 for x, 6 times 1 plus 10 equals 6 times 1 plus 15. Am I ever going to get the same answer by plugging in the same thing for x on each side? No. So this is literally impossible. It doesn't have a solution. And that's why I didn't finish solving the pink or the blue, because I wanted to see if something like this was going to bubble up. A has 2 very different things on each side, so I was likely going to be able to solve it and get x equals something. Let me show you. 5x minus 15 equals negative 3x minus 14. When I get the x's on the left and the constants on the right, add 3x to both sides. 8x minus 15 equals negative 14. Add 15 to both sides. 8x equals 1. Divide both sides by 8. I get x equals 1/8. Easy peasy. It gives me a singular solution. It gives me a solution. That is exactly what I'm looking for. Letter B gives me infinite solutions because both sides equal each other. Letter C, no solution, not possible. So that's really what I was looking for when I was solving without doing a whole bunch of extra work. A customer is comparing which kiddie pool they want in their backyard. Pool A measures 1 foot by 2 feet by 2 inches. And pool B measures 2 feet by 1 foot by 1 foot. What is the difference in the volume of pool A and pool B? What is the difference in the volume of pool A and pool B? So, key vocabulary words here. Difference, volume. So difference means the gap between them, or subtraction. Volume is the amount of 3D unit squares that can fit inside each pool. we can assume that these are rectangular pools, and this problem should say something to the effect of rectangular pool A measures 1 foot by 2 feet by 2 feet. Rectangular pool B measures 2 feet by 1 foot by 1 foot. And the volume of a rectangular prism is length times width times height. So step 1 is I need to find the volume of pool A, find the volume of pool B, and then subtract. However, one thing that I notice is that I have feet, 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 feet. And in my problem, I notice that I have inches. So I'm going to draw out pool A, pool B, and pool A measures 1 foot by 2 feet by 2 inches deep. And pool B measures 2 feet by 1 foot by 1 foot. I need to convert this into feet. Now, that seems impossible because 2 inches is not even a whole foot. It's going to be a fraction of a foot. But when I find the volume of pool A and pool B, I need to do it in units that are all the same. So pool B is 2 feet, 1 foot, 1 foot. So I'm going to do 2 times 1 equals literally just 2. Pool A measures 1 foot times 2 feet times 2 inches, and 2 inches is the same thing as 2 over 12. Thinking about the fact that we have a fraction, so this is a part of a whole. The whole foot is 12 inches, so a part of that is 2, so this equals 1/6. So 1 times 2 is 2, times 1/6 equals, when I multiply fractions, I can just multiply straight across. So I'm going to put this over an imaginary 1 because 2 over 1 is the same thing as just a plain 2. So 2 times 1 is 2. 1 times 6 is 6. So this equals 2/6, which is the same thing as 1/3 of a foot. I divided the top by 2 and I divided the bottom by 2. So it equals 1/3. Now I can just subtract pool A and pool B. So 2 minus 1/3 equals 1 2/3. Now, if you're like, whoa, Amy, you moved way too fast on that. How did you get that? 2 minus 1/3. 2 is the same thing as how many thirds? Well, 3/3 equals 1 whole. So how many third is going to be 2? 3 plus 3 is 6. 6/3 equals 2. So I could convert this to 6/3 minus 1/3, and that would give me 5/3, which is the same thing as 1 2/3. All righty. We are going to end a little early today. We're going to have a little shorter session because during the summer we have a little bit shorter sessions sometimes. So with that said, I hope that this was super helpful for you. Let me know in the comment box if there's something specific that you want to see me go over. I am going to go over Math 115, specifically numbers in algebra and algebraic thinking. So Math 115, numbers and algebra and algebraic thinking. I'm also going to go over a geometry problem that was specifically asked on our Facebook page that I think would be helpful for everybody. So I'm going to go over that next week too. But if there's something else that you want to see, please don't hesitate to let me know in the comment box. And I look forward to seeing you next week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.